Hello, all. Welcome to the tutorial. So today we'll be understanding how the evolution of Terraform state files has moved from S3 plus DynamoDB to support native S3 or native remote backends. Let's get started. So this is the traditional architecture which Terraform open source used to follow, where like the state files for Terraform or infrastructure as code was stored in S3 bucket in case of AWS cloud and blob in case of Azure, and similarly for other clouds. And we used to have one DynamoDB where we used to store the state of log files. So why this was required was like whenever we have multiple developers accessing the same source code and they are trying to modify the Terraform state files, which is storing the infrastructure state files. That is the state of all the infrastructure over the cloud. So if both of them commit at the same time, it used to have conflicts. Other base conditions. So for resolving that, we used to have the log part from DynamoDB configured. So once like developer A has acquired the log and he's working on the files by running the pipeline or maybe running from his local, so no one was allowed to change or access the state file during that time, and that is how we used to avoid a race condition. Now, the problem was resolved here, but the thing was like we need to have a separate table called DynamoDB, which was specifically for storing the logs and all. So as Terraform has advanced from 1.1 version, so there is no need of DynamoDB anymore, and the log itself is supported in the S3 bucket. So let's go to the next slide. Here we can see the traditional architecture where we are mentioning the DynamoDB table name and all of the things are like the bucket name, key. So key is the place where inside the bucket where is the state file stored. So this is the path for that. This is the DynamoDB table name, and this is the region, and encryption is true. So this was the Terraform code which was needed for the Terraform backend. Now going forward, as we don't need DynamoDB, so the syncing part of the state file as well as the lock is natively supported in the S3 itself. So again, the code remains the same. It's just like you need to use the parameter use log file equal to true, so which enables the native locking. And what technology it uses is like it is functioning with the help of e tags. So whenever some files are committed, so every time a new e tag is generated, which is unique, and if the e tag is same, it understands there is no change in state. And whenever a new file comes in, so a separate e tag is generated. That's how it knows the difference. There is some difference in the state file, and that is how the locking and other things are supported from here. So now the advantage of moving to the this kind of native locking is like you don't need to support extra DynamoDB table, so you can save the cost. Apart from that, whenever you configure the CI/CD for the infrastructure as code, so in that case you have earlier you had to provide in the policy and roles to have access to S3 as well as your DynamoDB table. So in that case, we are making it more secure as we don't need any DynamoDB table in the policy or role. And specifically in the S3, we just add one more in the description part to have more metadata maybe in the policy and to support the e tag. That is how the native support is there. And apart from that, you don't need to have expertise and have more complexity using DynamoDB because now it is natively supported. So that is how the Terraform has transformed the backend from using DynamoDB table as well as S3 to simple S3 with the help of native locking support.